A troubling new study from the University of Geneva has uncovered biological markers in adults with ADHD that closely resemble those found in individuals at risk for dementia. This research presents unsettling evidence that ADHD may not just be a childhood disorder with lingering effects into adulthood, but could also be tied to long-term neurodegeneration. The findings, published in Psychiatry and Clinical Neurosciences, reveal that ADHD patients exhibit increased iron accumulation in the brain and elevated levels of neurofilament light chain protein, NFL, in their blood, both of which are known indicators of Alzheimer's and other neurodegenerative diseases. The implications of these findings are significant and alarming. ADHD affects roughly 3.5% of adults worldwide, and while it is often discussed in the context of attention difficulties and impulsivity, this study suggests there could be much more at stake. Neurofilament light chain protein is released into the bloodstream when neurons are damaged, making it a well-established biomarker for diseases like Alzheimer's and Parkinson's. Similarly, excessive iron accumulation in the brain has been linked to oxidative stress and long-term damage to neuronal structures. These factors combined suggest that ADHD may be more than a behavioral or cognitive disorder. It could also be a condition with a progressive neurological impact that increases vulnerability to dementia later in life. What makes these findings particularly concerning is that the neurological risks of ADHD have been largely overlooked. While past studies have suggested an epidemiological link between ADHD and an increased risk of dementia, this is among the first to provide biological evidence supporting that connection. The study's use of quantitative susceptibility mapping, QSM, an advanced MRI technique, allowed researchers to measure iron accumulation with precision, revealing abnormal distribution patterns in the brains of ADHD patients. The correlation between these iron levels and elevated NFL concentrations in the blood suggests a process of ongoing neuronal damage, one that may not become evident until later in life, when cognitive decline accelerates. This research raises pressing questions about how ADHD is managed and whether early intervention could play a role in reducing long-term neurological risks. Currently, ADHD treatment focuses on symptom control, often through stimulant medications that impact dopamine levels. However, if ADHD is linked to a higher risk of neurodegenerative disease, then treatment strategies may need to be reevaluated to focus on neuroprotection rather than just symptom relief. Could reducing iron accumulation in the brain serve as a preventive measure against dementia? Could lifestyle interventions aimed at lowering oxidative stress make a difference? These are urgent questions that demand further study. The potential public health consequences of this research cannot be ignored. Dementia already affects 55 million people worldwide, with nearly 10 million new cases each year, and Alzheimer's alone accounts for up to 70% of those cases. If ADHD contributes to that growing burden, then millions of people may be unknowingly living with an elevated risk of cognitive decline. The fact that many ADHD patients already struggle with executive functioning and memory issues raises concerns about how these difficulties might worsen with age, particularly if underlying neurodegenerative processes are at play. There is also the issue of awareness. While the public has a growing understanding of conditions like Alzheimer's and Parkinson's, ADHD is still often dismissed as a minor inconvenience, particularly in adults. If this study's findings hold up in future research, then ADHD should be taken far more seriously, not just as a disorder that affects childhood development and daily functioning, but as a condition that may have profound implications for brain health later in life. Despite the study's alarming implications, there is still much that remains uncertain. More research is needed to determine whether interventions targeting iron accumulation could mitigate the risks, and long-term studies will be necessary to track whether ADHD patients with these biomarkers do, in fact, experience higher rates of dementia as they age. However, what is clear is that the neurological impact of ADHD extends far beyond what was previously understood. This research serves as a stark warning that untreated or poorly managed ADHD could come with hidden costs that only become apparent decades later. If confirmed, these findings could reshape how ADHD is diagnosed, treated, and understood, not just as a disorder of attention and impulse control, but as a potential early warning sign of cognitive decline to come.